everyone, welcome to the next session on operations research. In this session, we will take up the concept of dynamic programming in OR. Dynamic programming, abbreviated as DP, is a powerful mathematical tool used in operations research to solve complex optimization problems by breaking them down into simpler subproblems. It is especially useful for problems involving decision making over time, where the solution involves a sequence of decisions or actions. The key concepts in dynamic programming. The first one is optimal substructure. This means that the optimal solution to a problem can be constructed from optimal solutions to its subproblems. So when you're dividing the problem into subproblems, you first find the solution, and from the optimal solution obtained, you can hence find out the optimal solution of the entire problem. If you solve smaller subproblems optimally, you can combine these solutions to solve the larger problem optimally. The second one is overlapping subproblems. Many problems can be broken down into subproblems that are reused multiple times. Dynamic programming solves each subproblem once and stores the result to avoid redundant calculations while significantly improves the efficiency. So what you do is you divide into smaller subproblems and you are going to use them again and again, but you avoid resolving them, hence they are stored and then you can use the results whenever required. This will also improve the efficiency because you are not wasting time calculating things over and over again. Third one is memoization versus tabulation. Memoization, this is a top-down approach where you solve the problem recursively and store the results of subproblems in a table, often a hash table, to avoid redundant work. And tabulation, it is a bottom-up approach where you solve all possible subproblems starting from the smallest, iteratively building up to the solution of the larger problem. So there are two ways of solving: top-down approach or bottom-up approach, wherein you can have a problem which is solved recursively and you can store the results of subproblems in a table, as you can see over here, to avoid redundant work. Or what you can do is you can start with the smallest subproblem and slowly build up and then get the solution for the entire bigger problem. Dynamic programming approach. First is formulate the problem. Define the problem in terms of a series of decisions or stages. So when we solve the numericals, you will see that there are various stages in which the problem is to be solved. Identify the state variables and the decisions that need to be made at each stage. So when I solve the numericals, I'll tell you what is the state variable and how to make the decisions at every stage. Define the recursive relationship. Determine how the solution to the problem can be expressed in terms of solutions to subproblems. This often involves finding a recursive formula or transition function. So what you do is actually you write some function like f of x will be f1x1 plus f2x2. It depends on the number of state variables that you have taken and how many functions you are trying to solve, that is the decision you are trying to take, and accordingly you are going to make the equation. Initialize the base case. Set up the initial conditions or base cases which represent the simplest instances of the problem. So you need to set up the initial conditions and then figure out the solution. Then what you do is compute solutions to subproblems. Use the recursive relationship to compute solutions, typically using either memoization or tabulation. So either of the two techniques you can use in dynamic programming and you can find the solution. Construct the solution to the original problem. Once all subproblems have been solved, use these solutions to construct the optimal solution to the original problem. So once we solve, say, f1x1 plus f2x2, you may figure out in the next one what is f2x2 plus f3x3, and then finally you will combine f1x1 plus f2x2 plus f3x3. So you have initially solved the smallest subproblems, f1x1, f2x2, f3x3, then you have clubbed them into smaller subproblems again, and then finally you find the entire solution. So that is the approach of dynamic programming. Applications in operations research. The first one is finding the shortest path problems. Dynamic programming is used in algorithms like Dijkstra's or Bellman-Ford to find the shortest path in a graph with weighted edges. The problem is broken down into finding the shortest path from the start node to various intermediate nodes. So suppose if you want to find the shortest path, you can use this method of dynamic programming. Knapsack problem. This problem involves selecting a subset of items to maximize total value without exceeding a weight limit. Dynamic programming helps in building a solution by considering each item and weight incrementally. So this is another type of problem which you can solve. Third one is inventory management. Dynamic programming can be used to determine optimal inventory policies over time, considering factors like holding costs, ordering costs, and demand fluctuations. The fourth one is resource allocation. Dynamic programming helps in allocating limited resources optimally across various projects or tasks, considering constraints and objectives. So this is another important job which is done by dynamic programming, where you can allocate resources to your projects or your task, considering what are your constraints. Like suppose if you have a particular amount of resource in your inventory, or say you have some kind of objective to fulfill. For example, you know that you need to serve your customers in the next 7 to 15 days. So accordingly, you will do your resource allocation. See, at a time in a company, no one wants extra inventory in the shop floor, nor do people want extra inventory in the warehouses. So we want to buy as much as required and keep allocating to the shop floor as much quantity they require, and they can produce the products. So this is a very important aspect of dynamic programming. And the last one is project scheduling. Example, critical path method. Dynamic programming can be applied to schedule tasks in a project efficiently, considering dependencies and minimizing project duration. So once you talk about resource allocation or inventory management, project scheduling is actually a part of it, because you need to figure out in how much time you are going to make your products available to the customer, because customer always gives you a deadline. So whatever deadline you have decided upon, you need to work accordingly. So this critical path method is very important, wherein you decide what path you need to follow such that you make your products available to the customer in the shortest available time. Also, when you are on the shop floor, you would not want to waste time when the products change the machines. So what you need to do is you need to decide on the time required on one machine and then go to the next one, and accordingly. So we will also see the topic of scheduling soon, where I will tell you about this in detail. Also, we will take up these problems like critical path method and all in some other subject which I will take up. So the example is the Fibonacci series. To illustrate the basic idea of dynamic programming, consider calculating the Fibonacci sequence. The naive recursive solution has exponential time complexity due to overlapping subproblems. By using dynamic programming, either through memoization or tabulation, you can reduce the time complexity to linear. So you can see the recursive formula f of n. This is a mathematical formula. It is f of n minus 1 plus f of n minus 2. Base cases f of 0 is 0. This is the initial conditions, as we say, and f at 1 is 1. The dynamic programming solution: use a table to store results of f of I for I from 2 to n, iteratively filling in values based on the recursive formula. So this is an example of the use of dynamic programming. So in summary, dynamic programming is a robust technique in operations research for solving problems that involve making a sequence of interdependent decisions. By leveraging optimal substructure and overlapping subproblems, dynamic programming efficiently computes solutions to complex problems that would be otherwise computationally infeasible. You need to keep in mind that dynamic programming, as the word suggests, What is happening over here, if you observe, is everything is dynamic, it's in motion. The material in the inventory, the material on the shop floor, the materials which are getting produced, the finished goods which are going to go to the customers, and again the order will be placed, and again you need to keep on managing your inventory. The project scheduling keeps on continuing. Everything over here is moving. They are all in dynamic state. That is why the use of the word dynamic programming. So with this, I end the session. I hope you have understood the concept of dynamic programming. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.